Alright, so hopefully you guys have done the warm-up by now. Mr. McAtee is gone, and the sub's going to guide you through this video. You're going to start just by reviewing the warm-up. So for this first one, you should have seen that these two angles right here create supplementary lines. Because this one matches this, this whole thing would equal 180. So we're going to set it up equal to 180. 15 plus x plus 6x plus 60 equals 180 degrees. We have to combine your like terms, so this is 7x. 15 plus 60 is 75 equals 180. Keep working through so that x is by itself. And 7x will equal 105. Ooh, it's lagging quite a bit. So x will equal 15. That's the value of x. So remember, that's not the measure of the angle. To get the measure, you need to plug in x with 15. So it'll be 15 plus 15. Angle A is equal to 30 degrees. In the diagram above, angle C is the alternate exterior angle to angle A. Draw the angle in the correct space. So angle C would be right here. This is angle C. It is alternate exterior, opposite and outside, and that is congruent. Third one talks about translations. They move from 3, 5 to 0, 1. What are the coordinates of the point 3 or -3, -5 with the same translation? We should have started with a rule. So always begin with telling me what happened to x and what happened to y. So how did you get from 3 to -3? So how did I get from 3 to -3? Well, if you subtracted by 6, you would get -3. So this has to be x minus 6. 3 minus 6 is -3. Okay, they went from 5 to 1. So what would I have to subtract from 5 to get to 1? Well, 5 minus 4 is 1. So this would be y minus 4. There's my new rule. And now let's, oh, I did this completely wrong. We went from 3, 5 to 0, 1. Back up. You guys are probably shouting out blunders left and right. We went from 3, 5 to 0, 1. So to get from 3 to 0, we would subtract 3. To get from 5 to 1, I did that one, right? You would subtract by 4. Okay, there's your rule. Now let's use the point -3, -5. Subtract 3 from -3, and x would be -6. Subtract 4 from -5, and x is -9. Your answer is D. Okay. Let's flip to our AIM page. Today's AIM, students will be able to understand reflection across any line. any horizontal or vertical line. So Friday we learned how to flip across X and Y. Today we're learning how to do that from any line that we choose, not just the X or the Y axis. This is reflection. So just recording these notes to remind what a reflection is. It's a transformation that flips each point in the figure to be equidistant across any line of reflection. Across any line of reflection. So on the grid, we're going to draw and label triangle ABC, whose vertices have a coordinate of -1, 2, 2, 3, and 4, 6. Go ahead and pause. And where would that be? Okay, so hopefully we directed it to be looking like this. And that's ABC. I want to make ABC prime by reflecting it across X equals -2. So we're going to try to find triangle A, B, and C prime. And this time I'm not reflecting across the X-axis. They tell me the reflection should be across X is -2. So let's see if we can find where X would be -2. Well, this is X. And if I want to flip across -2, it would need to flip across this line. So I'm going to draw my line right here. And that's my reflection line. So this is the new point that I am using as my measure for reflection. Well, you probably are remembering back to where we had this rule where you could change one of the numbers to negative, keep the other one. If you're changing from a reflection other than X or Y axis, we can't use that rule. So we just have to use measurements to see what that would look like. Starting with point A, let's go over 1. Well, that hits our line of X is -2, so we're going to go one more over, and that would be A prime. Let's use B. We go over 1, 2, 3, 4. We hit our line, so go 1, 2, 3, 4 back, across, and that's B prime. C is a little farther out. Go 1, 2, 3, 4, 5, 6. We hit our line, so we go 6 over it. 1, 2, 3, 4, 5, and 6. That is C prime. Go ahead and connect your dots. That is your new reflected point. Let's mark what that would be. So A would be at -1. Or no, not -1, sorry. We're going to use this origin right here. So this is over 1, 2, 3, up 1, 2. This is over 1, 2, sorry, from here, from the origin, it's 1, 2, 3, 4, 5, 6, up 3, -6, 3. And C would be over 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3, 4, 5, 6. So what do you notice about the distance between the two shapes and the line of reflection? It is equidistant from this line of reflection. So each point is equidistant. From the line of reflection. And take a look at this. The rule that we used when we flipped across -2, you'll notice that the x values stayed the same since we flipped across x equals -2, or sorry, the y stayed the same. What changed was the x changed by -2. So this is kind of like your rule where you're going to do x minus 2, and then the y would stay the same. Okay, what angles and sides are congruent? Well, AC is congruent to A prime, C prime. Pause the video and see if you can find 2 more sides that are congruent. You should have found that AC was congruent with A prime, C prime, AB is congruent with AB prime, and BC is congruent with B prime, C prime. What angles are congruent? Pause this video and see if you can answer all 3. Alright, so hopefully you found that angle A was congruent with this angle A prime, B is congruent with B prime, and C is congruent with C prime. Let's do one more. Example 2, go ahead and pause this and plot the point XYZ, or the triangle XYZ, and then we'll reflect it. Okay, there's our triangle. Hopefully we found that, and it looks similar to this. We want to reflect this now across the line y equals -2. So if x equals -2 was on the x-axis, y equaling -2 would be on the y-axis at -2. 1, 2. A line would cross that point. Oh, I failed. There we go. A line crosses that point. Oh my goodness. Okay, last try.